So 19, 20, and 21, distance, rate, and time problems. What they want to get across is that the distance is equal to the rate times the time. And that when we're solving these, we might be doing one distance plus another distance to find a total distance, or we might be going somewhere and coming back where the distances are equal. We also have to be careful on these problems that just because we get it solved for one of the variables doesn't mean that's the answer to the question. So we always got to go back and say, what question do they want answered? So in this case, two trains leave the station at the same time. One headed east, so one's going to the east, the other's headed west. The eastbound train travels at 97 miles per hour. So for my eastbound train, if rate times time equals distance, I know that my rate is 97. My westbound train, 83 miles an hour. So again, rate times time equals distance. My rate is 83. How long will it take the two trains to be 288 miles apart? How long? What is their time? Well, if they left at the same time, they're going to be 288 miles apart at the same time. So I'm just going to use t for their times. So 83 times t is the distance of the westbound train. 97 times t is the distance of the eastbound train. If I add their two distances, I should end up with 288 miles apart. So I'm going to go ahead and combine my like terms there. If I take 83t plus 97t, I get 180t. So 180t should equal the 288 miles that they're apart. In order to solve that for t, I'm just going to go ahead and divide. So 288 divided by 180 gives me 1.6. Do not do any rounding. How long is it going to take them? This is in miles per hour, so it's going to take them 1.6 hours in order to be 288 miles apart. The next one. Two cars leave town 600 kilometers apart at the same time and travel toward each other. So this time one's going this way and one's going this way. One car's rate is 12 kilometers per hour less than the other. So one of the car, I'm just going to use R for its rate. We don't know what the rate of the first car is. The rate of the second one is 12 kilometers per hour less than the other ones. So 12 less would be R minus 12 for its rate. So one rate R, the other one 12 less than that, so R minus 12. If they meet in 3 hours, that means this one went for 3 hours, this one also went for 3 hours. Again, we know that they met and that their distance was 600 kilometers because they met in the middle, and so 3R plus 3R minus 36, using my distributive property, is going to equal the 600 miles they're apart. 3R plus 3R would be 6R minus 36 equals 600. If I'm going to solve that, I have to add my 36. So 6R equals 636. And then, of course, I'm going to divide by 6. So 636 divided by 6 is 106. R equals 106. Now, it wants you to find the rate of the slower car. You found the rate of this car right here. If this one is doing 12 less than that, it's going to be the slower car, right? So I have to take 106 minus 12 in order to find the rate of the slower car. 106 minus 12 is going to give me 94. Now this is in kilometers per hour, so you're thinking, oh, they're going really fast. But remember, kilometers per hour is not the same thing as miles per hour. And so you have to be careful. Just because you found one of the rates doesn't mean that that's the rate that they want you to put for the answer. That one's going to be faster than the other one. 21. Kiko, or however that's pronounced, drove to the mountains last weekend. There was heavy traffic on the way there, and the trip took 12 hours. When Kiko drove home, there was no traffic, and the trip took 8 hours. If her average rate was 20 miles an hour faster on the trip home, how far does she live from the mountains? So she's leaving home, going to the mountains, then she's going to come back and go back home, right? Still, we're thinking about rate times time, but this time those two distances should be the same. So, there was heavy traffic on the way there, and the trip took 12 hours. So my time here is going to be 12 hours. There was no traffic on the way, or when Kiko drove home, there was no traffic, and the trip only took 8 hours. So on the way back, her time's only 8 hours. Her average rate was 20 miles an hour faster on the trip home. So again, we don't know what the rate was on the way there, but on the way home, we know she went faster, and so we have to do R plus 20. So here, the rate on the way there is 12R. The rate on the way back would be 8R plus 160 if I use my distributive property. And so, or the distance on the way there is 12R, the distance on the way back, 8R plus 160. And those two distances should be equal. So if I want to solve these, I'm going to subtract my 8R. 4R equals 160, and then I'm going to divide by 4, so R equals 40. So, we found the rate on the way to the mountains. The question doesn't ask for the rate. The question says, how far away does she live from the mountains? So, if her rate was 40 and she went for 12 hours to get to the mountains, we have to take 40 times 12, the rate times the time, in order to get to the distance to the mountains. So 40 times 12 gives me 480 miles. So these ones are going to be kind of tricky because they do all kinds of twists and turns in there. Just keep writing down your examples so that you have plenty of examples to follow, and hopefully you will be able to catch on to these ones.